Hello Facebook friends, have a nice day. My video is about transistor. Transistor is a semiconductor device used to amplify and to switch electronic signals. It is composed of semiconductor materials, usually has 3 pins for connections to an external circuit. It is used for amplifying, controlling, and generating electronic signals. Transistors has 3 types of its materials uses. One is the BJT, means bipolar junction transistor. Second, FET, means field effect transistors. Third, IGBT, which means insulated gate bipolar transistors. These transistors are used for amplification and switching. They are used to control current and amplify input signals to a greater output signals. Now I will illustrate to you the example of the transistors. These transistors are the active components in the microchips or in the IC. The smaller transistor has a small amplitude of current and voltages, while the big transistor has high amplitude of current and voltages. Now I will show the illustrations of BJT transistors. There are 2 types of BJT transistors. One is the NPN transistors and the PNP transistors. One types BJT transistor has 2 diodes, common in the anode, which is the base, and the other side of diode collector and the emitter. And the PNP has 2 diodes, common in the cathode, the common base with collector and the emitter. The BJT transistor has 3 common modes of operation. One is common base configuration. Second, common collector configuration. Third, common emitter configuration. This is the transistor configuration: common base, common emitter mode, common collector mode. The base, the applied input voltage is positive. BJT transistor has 3 terminals consisting of 2 PN junctions. These 3 terminals of BJT are base, collector, emitter. A signal of a small amplitude applied to the base is available in the amplified form at the collector of the transistor. This provides the source DC power supply to carry out the amplification process. Next, I will show to you the illustrations of field effect transistors and IGBT insulated gate bipolar transistors. I will show to you the cross-sectional view of the following. This is cross-sectional view of FET. FET, field effect transistors, are used to control the flow of current. Device with 3 terminals: the source, the drain, and the gate. By the application of FETs used to control the flow of current, and the voltages to the gate, which in turn alters the conductivity between the drain and source. FET use electrons or holes as charge carrier in their operation. Generally, the display has high input impedance at low frequencies, and the most widely used field effect transistor is the MOSFET. FET fabricated in silicon integrated circuit. A single IC contains thousands of FET along with other components such as resistors, capacitors, and diodes. FET prepared for weak signal like wireless communication and broadcast receivers. This is the cross-sectional view of IGBT transistors, insulated gate bipolar transistor. It consists of 4 alternating layers, positive, negative, positive, negative, that are controlled by a metal oxide semiconductors, which is the gate structure. IGBT is the same as thyristor with a most monolithic oxide semiconductor gate thyristor. It is used in switching power supplies with high power applications like variable frequency drives, electric cars, trains, variable speed refrigerator, lamp ballast, arc welding machines, and air conditioners. It is designed to turn on and off rapidly. IGBT is the second most widely used power transistor, and after the power, the MOSFET. These transistors has many uses in the circuit. It can be used switch in the circuit, next amplifier in the circuit, next diode in the circuit, next voltage and current regulators, next variable resistance, and multivibrators. And also the common defects of transistors are shorted if we measure in the base emitter, base collector, and emitter collector. It can be blown or burned in the terminal of transistors. The most common defect of the transistors is leak transistors. You can read in the base emitter, base collector, or the emitter collector leaky resistance. Show to you the illustrations of the transistors in the circuit. These are transistors using switch and amplifier. If switch on in A, R1 is the bias resistor applied to the base of Q1. Q1 output applied to Q2. Q2 will not function, will not saturate. The R3, the bias resistor, applied voltage to the Q3. The Q3 will switch on, and the negative output of Q3 applied to Q4. Q4 will saturated or switch on. The LED will lights the Q1 transistor act as a switch. The Q3 and the Q4 act as the amplifier. This is the illustrations of transistor using switch and amplifier. This is a multi-vibrator. The basic transistor circuit for a multi-vibrator produces a square wave output from a pair of grounded emitter cross-sections coupled transistors. Both transistors, either in P-in or P-NP in the multi-vibrator, are biased for linear operation and are operated as common emitter amplifier with positive feedback. The R2 and the R3 are the bias resistors. This is the illustrations of transistor series voltage regulator. This transistor in series to the sine regulator put in parallel to the load. It works as a variable resistor regulating its collector emitter voltage in order to maintain the output voltage constant. The output voltage is maintained by the sine voltage, which is constant, as both of them are maintained equal. Any change in the input signal is indicate the change in emitter base voltage output voltage. Both regulators are maintained constant output voltages instead of any kind of fluctuation in the input voltage applied or variations current drawn by the load. This is fixed positive voltage regulator. I will show also to you the illustrations of the maximum voltage in the transistor. This is the output voltage maintained by the sine voltage. The maximum voltage 15 volts minus 0.7 volts equals 14.3 volts. The output voltage in the load is equals to 12 volts minus 0.7 base emitter volts equals 11.3 volt DC. Voltage drops in the transistor equals 15 volts minus 12 volts equals the 3 volts and equals 0.7 volts bias voltage base emitter. If there's no resistance load, the output is high. Next, I will show to you the actual testing of the transistor. Hello my dearest Facebook friends, I will show to you the testing of transistors. The transistors here, I will show to you the examples of my transistors. These are of the one. These are the transistors that I will illustrate to you. This one. No reading. This one there is reading 0.513. The other one 0.570. The common of the transistor is in the positive probes. This is the common of the transistor. Which is PNP. The transistor is PNP. The reading of the base in the other terminal 0.513 and the others 0.570. This 0.513, this is the collector at the middle. This 0.569, this is the emitter. This is the emitter. This one emitter, collector, and this one the base. How we know that it is the collector and the base? The reading of the base collector is smaller than base emitter. 570, 513. This is base collector. This is the emitter. This is the emitter. This is the collector. At the middle, this is the base. Now we go to the transistor that is burned. There is reading. There is reading. If we reverse, there is also reading in the multimeter. All the terminal pin of the transistor, there is reading. So this transistor is leaked, partially shorted. This transistor is bad. Other one, this is a bigger transistor. We can check where is the base in the emitter in the collector. This one, no. No. No, we reverse. This one, 0.507. Other terminal 0.556. This is PNP. 507, 556. This is the base of the transistor. This one, the base. In the positive multimeter, the test probe, positive test probe, it is the PNP. The collector is in the center. Base collector, base emitter, 555. The collector, base collector is lower reading than the base emitter. This one. So this transistor also is good. Even you have to reverse. Good. In reverse, there's no reading at all. See, there is no reading. This other one, check this one, there is a reading 640, 0.641. The middle 0.640. The base is common in the test probe in the black color, so it is the NPN. This transistor is NPN. This is the 234. BD, this is B234 in the number of the transistor B. So we will determine the collector of the transistor. The middle is the collector of the transistor, 0.641. 0.39 and the other side 0.641. This is the base emitter in Pin. The center is the collector of the transistor. Transistors, I will tell to you the technique of a transistor. The transistor in the middle of the transistor has no emitter. You cannot find in the transistor in the middle emitter. It is always in the outer side. This is the technique of checking the transistor, and also you can determine the letter of the transistor. A and B is PNP. C and D are the NPN transistors. These are the actual encountered in troubleshooting of the transistors. Thank you so much, my dearest Facebook friends. Hope you will understand. I will show to you the transistor testing, how to know the base emitter and collector. Thank you so much, my dearest Facebook friends. This is the end of my video. Bye bye.